Hello friends, I am Professor Anil Disle, working as Assistant Professor in Vidya Prestans Kamal Nayan Bajaj, Institute of Engineering and Technology Baramati. Today we are going to focus on very introductory part of optics, that is introduction to electromagnetic waves. So we start with waves. So most of the waves are either longitudinal or transverse, means they will vibrate in the direction of propagation, or they will vibrate in perpendicular to the direction of propagation. So sound waves are longitudinal, means they will vibrate in the direction in which they are traveling, and electromagnetic waves are transverse, so they will move up and down, so they are vibrate perpendicular to the direction in which they are propagating. So basically this is the nature of the transverse waves, and the distance between two crest or two trough is called as wavelength. So it is a complete one cycle, so it can be distance between two crest or two trough that we call as wavelength, and the distance between origin is called as amplitude. So distance between origin to the maximum, either a trough or crest, that we can call as amplitude, and this distance is called as displacement. Now what does this picture show about the relationship between frequency and wavelength? So if you see this spectrum or this diagram, it shows that the wavelength goes on decreasing and frequency goes on increasing as we go from left side to the right side. So here this is very low frequency and we are having a highest wavelength, and as we go in this direction the wavelength goes on decreasing and frequency goes on increasing from extremely low frequency to the radio waves, microwaves, infrared, and these are visible spectrum in which there are 7 colors: ultraviolet radiations, X-rays and gamma rays. And these are the different sources from which we are getting these radiations or this part of the electromagnetic spectrum. So there are power lines, AM radios, FM radios, microwave ovens are there, radiant heat that comes in infrared, or this is the welding that comes in near ultraviolet radiations. The medical field, they are related to the X-rays, and these the nuclear or chain reactions where the gamma rays will get produced. So radioactive sources will generally produce gamma rays. Now what are the types of the radiations? So radio waves having lowest energy electromagnetic radiations. So energy is very less. So if you see the equation, E is equal to h nu, hf for h nu, so where nu is the frequency and radio wave is having highest wavelength. So wavelength is more, so obviously frequency is very less, and if frequency is less, h is constant, so we can say that energy of these waves is comparatively less as compared to the other spectrum of the EM. This is very low frequency range, this is low frequency range, and this is the AM, or these are the short wave, middle frequency or high frequency, and as we go in this direction frequency goes on increasing. So this is the television, or this is the satellite communication radar systems. So this frequency starting from 3 kilohertz and it increases 3 mega, it goes up to 300 gigahertz. So electromagnetic waves, these are produced by the moment of the electrically charged particle. Means to produce the electromagnetic wave we have to vibrate the charged particle. So moment of charge, electrically charged particle can produce the electromagnetic waves. They can travel in vacuum, they not need a medium to travel, as like sound wave require material medium since they are mechanical, but these are the electromagnetic waves and doesn't require any kind of material for their propagation or for their travel. They can travel at the speed of light, that is c, where c is 3 into 10 to the power 8 meter per second, and also known as electromagnetic waves. So if you see this picture says that again if you go from this direction to this direction, so wavelength goes on decreasing and frequency goes on increasing, and these are the picture which shows the wavelength of the particular spectrum or particular region. So if you see this higher part of the electromagnetic spectrum, so the wavelength is very high, and that wavelength may be at the range of Mount Everest, and as you go in this direction the wavelength goes on decreasing, so skyscraper, humans, or fingernail, pinhead, dust, and it goes here up to atomic level. So if you see this spectrum, gamma rays and X-rays, so this spectrum, gamma rays and X-rays, the wavelength is very less, and this can be comparable to the atomic size also, that can be in angstrom unit also. So let us focus on the radio waves. So this is the radios, AM, TV and FM, and their range can be from kilometers to some centimeters. So these are the longest wavelengths of the electromagnetic waves, And the uses are, they can use in television broadcasting, they can use in walkie-talkies, they can use in radio communications, AM FM broadcast radios, heart rate monitors. They can use in, some part can be used in cell phone communications, not more. They can use in MRI, that is magnetic resonance imaging. Uses short wave radio waves with a magnetic to create an image. Now let us focus on the microwaves. So wavelength of microwaves can be from millimeter to meter, and this can be from 300 centimeter to 0.3 centimeter also. And these are the different bands of the microwaves. They can be called as L band, S band, C band, X and K bands. Now what are the uses of microwaves? So microwave ovens are there, so generally used for cooking purpose, heating purpose. Bluetooth headsets or devices in which we use microwaves. Generally for mobile communication, most of the part of microwaves is used. This also used in radar system, broadband wireless internets, radar system is also there, and can be used for GPS also. Now let us focus on the infrared radiations. So as we go from that radios, micros, infrared, the wavelength goes on decreasing and frequency will goes on increasing. Now here the wavelength goes on decreasing. So which was started in kilometers, now it came in micrometers. So infrared radiations can be have wavelength of few micrometers, 300 micrometers to 3 micrometers. So they are far infrared, mid infrared and near infrared. So wavelengths in between microwaves and visible light. The uses are night vision goggles. So generally these infrared radiations create the thermal images. So generally used for night vision goggles. They can use in remote controls also. Short distance communication. They can use in remote controls. Then heat-seeking missiles likewise. Now the most important part of the electromagnetic spectrum is the visible light. So in which all 7 colors we can have. So the pattern that we call as Jar pattern: violet, indigo, blue, green, yellow, orange and red. So this is the visible light spectrum, which can start from 7,000 angstrom unit to 4,000, or 0.7 micrometer to 0.4 micrometers. So starting from near infrared to ultraviolet radiations. So this is the rainbow that we can have, having the 7 colors. Only type of electromagnetic waves able to be detected by the human eye. So this is the only part of the electromagnetic wave that we can see. Violet is the highest frequency. So as we go on this direction, again the frequency goes on increasing. So violet having the highest frequency and red having the highest wavelength. Red light is the lowest frequency, so frequency will be less here. Now ultraviolet part. So you might have seen these ultraviolet radiations. So their wavelength can be in micrometers to nanometers. So they are near EV, far EV and extreme EV. Can be starting from 0.3 micrometer and can go up to 3 nanometers also. So they are the shorter wavelengths than visible light. And the uses are generally security purpose, security images on the monies. Now the frequency is very high, wavelength is very less. The frequency of this ultraviolet radiation is very high and they can penetrate our body. Up to visible penetration is not there, but from ultraviolet radiation they can penetrate your body. Since frequency is very high, and if the frequency is high, energy is obviously high, so they can penetrate our body. They are harmful to living things also. Used to sterilize medical equipments, generally used in water purifications also. And from sun also we are getting few part of the ultraviolet radiations. Nearly 8 to 10% radiations from the sun that we get, they comes in ultraviolet radiation. There are too much causes in sunburn. Extremely high exposure can cause skin cancer also. Now X-rays. So this picture you might have seen in the airport. So your all luggage and your bags will get scanned. So having very high frequency and low wavelengths. So wavelength can be in nanometer to 3 nanometer to 0.03 nanometer also, but having very highest frequency. Generally this picture also you might be familiar with. So X-ray. So this is related to the medical, to take the picture of your body to detect whether the bones are getting crack or not. So these are very tiny wavelengths having very high energy because frequency is very high, and the uses are, they can generally use in medical imaging, airport security, moderate does can damaging to cells also. And this is the last part of the electromagnetic radiations. They are called as gamma rays, having very shorter wavelength and very high frequency. So wavelength can be 0.003 nanometers. So the wavelength of these gamma rays can be in angstrom unit, and generally this medical field applications, few medical field applications are there. Gamma rays generally they produces in nuclear reactions, chain reactions. They are the smallest wavelengths and very high frequency. So this is the last part of the gamma rays, and having very less applications because to handle the gamma rays is very complicated, since they are very high frequency and they can easily penetrate your body and can damage your tissues also. So there are few applications of gamma rays. Generally they can use in sterilize medical equipments and cancer treatment to kill cancer cells, kills nearly all living cells. Thanks.